So here's example number 2 for our free fall problems. We have Mrs. Stewart throws a tennis ball straight up into the air at 2 meters per second. What maximum height above Mrs. Stewart's hand does the tennis ball reach? So this was that special case where that I was talking about before, where if we have a tennis ball being thrown up into the air and I want to know the maximum height, we have to remember that when that tennis ball goes up, 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 it's slowing down, slowing down, slowing down. It then stops at the top and it turns around and then speeds up toward the ground, which means that our final velocity at that maximum height point is going to be 0. So that's one of those hidden givens that I talk about. It's something that you have to infer from the problem and kind of get from the problem, but they don't really tell you that final velocity is 0. We also know that I throw the ball up at 2 meters per second. So that means my initial velocity is 2 meters per second. And then I want to know the maximum height. Now we say that we start at a height of 0 and then our maximum height will be our final position. So really what I'm solving for here is my change in position because that will be the height. And in this case, we're talking about a vertical position. So I'm going to say delta y equals question mark. And I know I call my initial y because really delta y, right, is y final minus y initial, final position minus initial position, but the initial position here is 0 because that's my hand. So really my delta y is my final position, which is what I'm trying to find. And then the last but not least, our last hidden given here is that the acceleration of gravity is a negative 9.8 meters per second squared. I make it negative because it's pointed down and we know this tennis ball is moving upward, and I said that that's a positive 2 meters per second. It's a positive change in position, and therefore my acceleration of gravity will be negative. So the equation that I use here is final velocity squared equals initial velocity squared plus 2 times acceleration times delta y. In this case, final velocity is 0. And then here I'm just going to plug in my numbers. So I get 0 equals initial velocity of 2 meters per second squared plus 2 times acceleration, which is a negative 9.8 meters per second squared, times delta y. I'm running out of room a little bit. And so I get here 2 times 2 is 4. 2 times negative 9.8 is a negative 19.6. So I get 0 equals 4 minus 19.6 times delta y. And then I subtract 4 from both sides. So I get a negative 4 equals a negative 19.6 times delta y. Divide both sides by 19.6. Negative 19.6. And I get my change in position is equal to about a 0.204 meters. And it makes sense that I get a positive number here because I have a negative divided by a negative. And it is going up, so I should get a positive change in position.